Hello and welcome back to another video. In this problem, we're told that when laboratory vats are exposed to asbestos fibers, some of them develop lung tumors. The table lists the results of cellular experiments by different scientists. So first, in part A, we're asked to find the regression line for the data. So the easiest way to do this is you can find it online, there's calculators to do it, or it's built into your graphing calculator. But either way, you input the points, and you're going to get y is equal to 0.019x plus 0.305, roughly. And this is the line that minimizes the distance between the line and all the points. So in B, we're asked to make a scatter plot and to graph this line in it. So we start at 0 and go up to 3,000 on the x-axis. So we can say this is 1,000, 2,000, and 3,000. And on the y-axis, we're going from 2% to 50%. So this can be 50%. And now we can graph the scatter plot. So to start out, 50 is very low on the whole span of 3,000, so that we can right next to the y-axis, and its value is 2, so it's also very low, so that's going to come in around there. Next we have 400, it's right about here, and it is a value of 6. 900, a little bit under, 500, we have a value of 5, so exactly here and exactly halfway to this 10 marker. This is 10, 20, 30, and 40. At 900, just under 1,000, we're up at 10. And at 1,100, a little bit after it, we're all the way up at 26. At 1,600, a little bit after the 1,500 mark, we're at 42. At 1,800, we're at 37. At 2,000, we're at 38. And at 3,000, we're at 50. So we have these graphs. These points graphed, or as to graph the regression line. Now, the easiest way to do this is just to say, okay, we're basically starting at the origin, right? We're starting at 0.305. And let's pick a point, let's say x is equal to 3,000, 0.019 times 3,000 plus 0.305. And you will get that this is equal to 19 times 3 plus 0.305 equals 57.305. So it's going to overshoot this a little bit, going into the graph, but this is the general regression line. Typically on a regression line on a hand-drawn plot, it's not super helpful to get it this accurate. However, they're asking, does the regression line appear to be a suitable model for the data? So we actually want it as close as we can possibly get. And here we can see that the data is roughly following a linear pattern. None of these points are too far away. This point right here at 1,600 is the farthest away, and even that's not too far relative to the whole span of the data. So we could say, yes, it is suitable, or it appears to be suitable. And C, what does the y-intercept represent? It represents y when x is equal to 0. What does that mean? It's the percentage when the asbestos is equal to 0. So there's 0.3% of mice are expected to develop lung tumors when there's no exposure to asbestos.